So today in class we learned how to determine the net ionic equation. So we're going to use the reaction of silver nitrate with magnesium chloride to figure this out. So I've already started this out by writing my reactants. Now I need to predict the products. So I know that the silver will with chlorine, and I look at my solubility rules from the past unit. And I know that AgCl or silver chloride is solid, and I then get magnesium nitrate. Kind of run out of room there. I'll have to write that below. We get MgNO3, 2, and that's also aqueous. Sorry about that. So to get the net ionic equation, the first thing I have to start out with is I need to figure out the total ionic equation. So I need to look at the ions. The other thing I didn't do is I didn't balance my chemical equation. So I'm pretty sure I'm going to need to do a 2 here, a 2 here, and I think that is balanced now as well. So the next thing I need to do is I need to write out the individual ions in solution. So if I have an aqueous solution, remember that the ions dissociate or separate. So I think, look at it this way. I have Ag, which is 1 positive, and I've got NO3, which is 1 negative, and you have to think to yourself how many of each of these I have, and look up at the coefficient up here, and you'll see that you need to have 2 and 2, sorry about that, it's hard to write backwards, plus Mg, which is 2 positive, and chlorine, which is 1 negative, and this is that moment where we can look and say, okay, we've got 1 chlorine here and 2 chlorines here, so we have to make that balance. The other thing I can see I'm forgetting is that all of these are aqueous ions. I need to remember my state. Okay, so then we can draw that a reaction occurs, and we rewrite the solid AgCl because it's a solid. It's not dissolving in solution, so we have 2 AgCl, and we include that it's solid, plus, and now we can rewrite our ions, so we've got Mg, which is 2 plus, right, this is getting a little bit messy, plus NO3, which is 1 negative, and please take a second and look that it's, again, it's a 2, there's 2 NO3s in our chemical formula, so we need to balance this and write a coefficient of 2. So in class we talked about spectator ions, and these are ions that aren't participating in the reaction. You can find them in both sides of the chemical reaction in the exact same form. And so these spectator ions are just merely watching the reaction. They're not taking part in the reaction. So if you look, you've got an NO3 right over here, and you've got another NO3, and they both there's 2 of them. You've got a Mg2 positive and an Mg2 positive. So now we've cancelled out the spectator ions, and right before we did that, we determined that this all right here is our total ionic equation, and now we need to figure out our net ionic equation. So what I'm going to do is I'm just going to write what remains. So I've got 2 Ag1 positive, that's aqueous, plus 2 Cl1 negative, and again that's aqueous, and they are going to react to form 2 AgCl solid. And when you look at this as well, you can see to yourself, well, this is a 2, this is a 2, and this is a 2, so you can reduce that further down to just being, let's see if I can erase that, probably not, nope. You can just reduce this or simplify this further to Ag1 positive aqueous plus Cl1 negative aqueous forms AgCl solid. And that final thing I just wrote right here is my net ionic equation, and before I started to cancel out, this was my total ionic equation. So there's my total, and here's my net. Alright.